Okay, good day class. Alright, so today we will go to the last part of chapter 4, which is 4.8.2, roots of complex number in polar form. Alright, so the last video we have learned how to use or how to find the power of complex number in polar form. Alright, where your n is any integer. But today we are going to see how we are using the De Moivre's theorem to find the roots of a complex number in polar form. Root means n not integer anymore lah. N will be anything in the fraction form. Alright, 1 over p. Here must be 1 lah. If it is not 1, that means that you have to use both power and root. Alright, so n is 1 over p. Okay, so let's see how we are going to use this De Moivre's theorem to find the roots of a complex number. Alright, so let's say you are given two complex number, z equals r cos theta plus I sin theta, and another complex number w, which is sine cos alpha plus I sin alpha. Alright, so let's say the w is the nth root of z. N root of z means like this. W is the n root of z, or we can write it in the form z to the power of 1 over n. Alright, then w is equals to z. So it is something like this. Alright, so w is equals to the n root of z, or z to the power of 1 over n. So the next step, if I add power n to both sides, alright, if I add power n to both sides, therefore wn will be equals to z. N and n simplified. Okay, so now we will see how we are going to use the De Moivre's theorem to find the roots, to find the roots of a complex number. Alright, so use De Moivre's theorem. We have w power n is equal to z. This is z given just now. This is z. Alright, and this is w just now given. So from here we already proved z is equals to w to the power of n. Alright, and by using the De Moivre's theorem, if w to the power of n, then the modulus also power n, then the argument multiplied with n, right? That we learned the last video. Alright, so left hand side is z. Z is r cos theta plus I sin theta. So right hand side is the w to the power of n. So this one. Alright, so from here you see that the modulus of the root, because we want to find the root, right? Okay, so the modulus, because we want to find the n root of z, so w is n root of z, right? So the modulus will be equals to s power n, because equality, right? So your s, because w is the n root. See, originally w is the n root of z, so we want to find w, we want to find x, s and alpha lah, right? W is the n root of z, so to find n root of z we have to find w, means we have to find s and alpha. So from this relationship we know that r equals to sn, because this is definitely given. Alright, and the n root is the one that we want to calculate. So r equals to s power n, so the s, this s is w, right? W modulus for w, which is the root. Alright, which is the root. So the modulus for the root will be r to the power of 1 over n. We add power 1 over n to both sides. So this one simplified left s lah. Alright, so this is how we calculate the modulus of the root. Okay, then how about the argument? So here is cos, we look at this one. So cos n alpha same as cos theta. Okay, and we know that theta is the argument, but n alpha, we know that cos repeat, cos is a periodic graph, right? It's repeat every 2 pi. Remember 360, it repeat every 2 pi. So therefore n alpha equals to theta. Alright, and it should be at 2k pi. Because cos repeat every 2 pi. One cycle every 2 pi. So k is how many times is repeat lah. Alright, so n alpha not direct equals theta, so n alpha should be equals to theta plus 2k pi. Alright, and alpha equals to theta plus 2k pi over n. Okay, so remember this. Alright, so this is how we, because the n root of a complex number is w. So to find w, we want to know the modulus of w. So this is a modulus. Alright, it's just n root of the power of z, and the anchor, the argument will be this one. Alright. So let's go back to the notes. So we are actually, what I explained just now is related to all this lah. Also use the De Moivre's theorem. We have Wn equals z, which is s. This is what I have informed just now. Then we compare. Okay, we compare the modulus. Then we compare the argument. All right. So thus the n root of z will be this one. This is a formula. Okay, so remember to find the n root. To find the n root of a complex number is this. All right. So what is k? So k will start from 0, 1, 2, 3, so on until n minus 1. This n. So if n is 8, then until 7. But start from 0 ma. So 0 until 7 means you have 8 root lah. If n is 7 means you should have n different answers. Alright, remember before this, in the Cartesian form, we already learned a square root of a complex number is another complex number. Remember we have learned this one? Square root of a complex number will be another complex number. So do this one. Cube root of a complex number is still a complex number. And in Cartesian form, we only learn up to square root, right? So after we solve the simultaneous equation, then we know that we have two answers. Remember? If square root, it will give us two answers. Not in conjugate pair. Okay? So if the first one is x plus yi, normally the next one will be minus x minus yi. Alright? So if square root means 1 power 1 over 2, right? N is 2, so 2 answers. So if cube root 1 over 3, then you should have 3 answers. If fourth root 1 over 4, then you should have 4 answers. Alright, for the roots. Excuse me. Okay, so this is the formula. Alright, therefore in general, root of complex number is, if you are given a complex number z in polar form, alright, so n will be any positive integer, then z will have n different nth root. Or let's say, for example, 1 over 2, so 2 different roots. If 1 over 3, 3 different roots. Alright, and the formula is like this. Normally the root we use w lah, wk. K refer to this one. Is it okay? So very simple, just use formula only. Alright, and you, of course, you must memorize this formula. It's not given in the formula list. Alright, so there are something that we have to bear in mind related to this formula. Okay, number 1, for each nth root of z, now this is z, for each n root, the modulus is r to the power of 1 over n. Means all roots will have the same modulus. Alright, if a complex number have 4 roots, then all the 4 roots will have same modulus. Alright, and number 2, the argument of each nth root exceeds the argument of the previous roots by 2 pi over n. Using this formula, by 2 pi over n plus 2 pi over n. Each time add 2 pi over n. It is the argument start with theta over n. This one originally. The first root, because k equals 0 my first root. So the first root, the argument is theta over n. Then each time increase by 2 pi over n for the consecutive roots. Alright? Therefore, the nth root of z, it lies equally spaced on the circle with radius r to the power of 1 over n. This is the modulus lah. What is the meaning of lies equally spaced on the circle? Okay, we will see one example. So my textbook is page 207, example 4.16. Alright, so you can Open your textbooks. All right, 207. Okay, this is the meaning. See? So this is the first one. The first root, P1. This is the first root with this argument. All right, so the second root will add. So you see, from the first argument, theta plus n, you add another 2 pi over n. Then add another 2 pi over n, to get all the roots and so on. This is the meaning of the number 2. All right, and the meaning of number 3. All right, lies equally spaced is this one. Let's look at example 4.16. Let's say you have z cubed minus 1 equals 0. Okay, solve means find z lah. Solve means find z. So z cubed equals 1. Also, find z means find the cube root. So because it's cubed, so there will be 3 cube roots. So writing z in polar form, sub into the formula. Later we will go to the detailed step lah, when I discuss the example. First root, second root, and third root. Alright, so you see how they label it on Argand diagram. Okay, first root is 1. So here, this is a z1. Alright, so this is a z2. This one, z2 is here. And z3 is here. Alright, so 3 roots. And you see that this 3 root, the meaning is lies equally spaced on the circle. Means that these 3 lines, you see, these 3 lines separate the circle into 3 equal parts. Remember, one circle is 360 degrees. Alright, so divided by 3, right? So means the angle between each root will be 120. Will be 120, 120. See, this is the meaning. Alright, so if 4 roots, so the angle between each root will be 90, right? This is the meaning. So later you will see in STPM, after you are asking to find the roots, they will ask you to block the Argand diagram. So the angle must be equally. Alright, so this is the meaning. Alright, so it's just that simple to find the roots of a complex number. Just remember this formula. And to find roots, you have n roots. Alright, if power 1 over n, then you have n roots. Alright, so I will show you the detailed steps. Okay, so in your textbook also, after example 4.17, you can go through yourself lah. Example 4.17, 4.18, they all explain a very detailed step. Okay, how to find the root. 4.19 also. 4.19 also. Okay, you can see how they find the roots. Okay, as example. Alright, okay, so next we will go to example 4.8.2. So first question, checkpoint 4.4. Question 9 to question 17, all related to roots. So please complete it. Alright, so I will discuss question 2, STPM 2014. Alright, the first part actually we have done. Express the complex number in polar form. This one we have done. Then hand solve. So altogether 9 marks. See? Alright, question 3 I want you to do as quiz. So today only 1 question for quiz. After you finish your video, please complete question 3 immediately and put it into the Google Drive. Alright, question 4 will be your homework again. Alright, actually question 4 also we have done part 1 and B, A and B. Given Z and W, I hope you still remember. They want you to find W. Then state the real and imaginary part. B, express W in polar form. These 2 we have done. So you just need to complete C. Use the De Moivre's theorem, determine the cube root of W. Cube root 1 over 3. But they want you to give your answer in Cartesian form. Of course, in the process, to use De Moivre's theorem, you have to use De Moivre's theorem, you have to use polar form. So after that, you convert into Cartesian form. Alright, so this is your homework. Okay, and I will discuss question 5 also. Okay, so I will discuss question 2 and question 5. Alright? So please see this detailed step, the correct detailed step. Okay, so number 2 is STPM 2014. As I say, express this in polar form we have done. Then you're asking to solve z cube equals this. Z cube equals this one. Alright, because we need it in polar form, right? Okay, so this is STPM 2014. Alright, so can see. Alright, can see it? Okay. So first, express this one in polar form. Okay, I repeat again, never mind lah. So W is this one. So modulus is this. Modulus, this one square plus this one square. And argument is arctangent y over x. So always label. So x is square root 6, y is negative square root 2. So it's here, fourth quadrant. So you know that it is a negative angle. Alright, so this is actually 1 over square root 3, which is 30 degrees. 1 over square root 3 is 30 degrees. Okay, so it's pi over 6 lah. But because negative angle, so it's negative pi over 6. Alright, argument. So W will be modulus cos argument plus I sine argument. Because it is negative angle, remember? So it becomes negative here lah. Alright, so you can express your answer until here or here, both can. But remember, for the next step, we must use like the original one. Okay, we must use the original one. Don't use the one that you factorize out the negative. Alright. Okay, so the next step is you're asking to solve this equation. So you're given z cube equals this thing. So solve means find z lah. Or solve means find z or find the roots. So z will be cube root of this. Alright, z will be cube root of this. Or I add cube root to both sides lah actually. Alright, so 3 and 3 simplified. So z will be cube root of this. Alright, so remember this formula. Remember this De Moraes formula for the roots of complex number. So just sub in. Alright, so the formula is r to the power of 1 over n. R of this. So we already calculate here lah. Argument, modulus. So 2 square root 2 to the power of 1/3. R to the power of 1 over n ma. Then cos theta plus 2k pi over n. So this is your theta, right? Negative 1 over 6 pi. That's why I say use back the original one. Don't use this one. So negative 1 over 6 pi plus 2k pi over 3. Your n is 3 ma. Alright, so sine also the same. Okay? So the formula for the root is this one. For k equals 0, 1, and 2. Because n is 3 ma. Alright, so 0, 1, 2. So 3 answers. Okay? So after we write this general one, write out the general one. So the next step, we calculate one by one, our roots. Okay? So when k equals 0, follow this one. When k equals 0 is the first root. So I label it as Z1. Okay? So the modulus 2 square root 2 to the power of 1/3 is actually square root 2. Maybe some will want to see how it can be. Alright, 2 square root, right? Can see? 2 square root, this one, this one. Okay, can see, this one. Or 2 square root 2 to the power of 1/3. So this is 2. Square root 2, I can write like this. And to the power of 1/3. Alright? Then after that, 2 to the power of 1/3. So 2 1/3. Multiply 2 to the power of 1 square and 1/3. So 1 over 6. Right? So same base. When multiply, we add the power. Alright? So 1 over 3, I can write as 2 over 6, right? Plus 1 over 6. Alright? So this is 3 over 6. So 3 over 6 means simplify 1 over 2. So 2 to the power of 1 over 2 is square root 2. Alright? This is how we do it. Or I think you use calculator also can give you the answer. Square root 2. For those who have a new version of a calculator, maybe they will show you straight away in this form. So remember, it must be in the exact form. Don't express it in decimal, okay? Alright, so after simplified, the modulus is square root 2. Okay, when k equals 0, the first root is, so cos negative 1 over 6 pi, because k is 0 ma, so plus 0 over 3. So sine also the same. Alright? So negative 1 over 6 pi over 3. So negative, negative 1 over 18 pi. Alright, negative 1 over 18 pi. Because of the negative lah, because of the negative, so I write in this form. Okay, but you remember for this one, the anchor is negative 1 over pi. The anchor is negative 1 over 18 pi, sorry. Negative 1 over 18 pi. I simplify into this form only. Okay, so you see, I write here, negative 1 over 18 pi, right? Pi is 180 degree, right? So it's 10 degree. It's negative 10 degree lah. Okay, so I draw it first. So the first root Z1 is here because negative 10 degree ma. So this line represent the first root. Alright, okay, then second root will be k equals 1. No? First one k equals 0. Second one k equals 1. So when k equals 1 is the second root. Alright, modulus same. Then cos negative 1 over 6 pi plus 2 pi because k equals 1 ma. So 2 pi times 1, 2 pi lah, over 3. So this one also the same. Alright. So when you calculate negative 1 over 6 pi plus 2 pi over 3, the answer is positive 11 over 18 pi. 11 over 18 pi. Okay, this is positive anchor. Alright, so 11 over 18 pi. Pi is 180, right? So means 110 degree. 110 degree. So the second root is here. Okay, same, length r same. So the argument for the second root is 110 degree. So from here, 110 degree. See? Okay, the third one. Third one, I want to write it in more complete lah. So when k equals 2 will be your third root lah, Z3. Okay, but I want to explain the argument first. So we know that the formula for anchor is this one, right? So the new argument is negative 1 over 6 pi plus 4 pi, right? Because k equals 2 ma. So k equals 2, so 4 pi lah, over 3. Alright? So after you simplify this one is positive 23 over 18 pi. Positive 23 over 18 pi. See? This one more than 1 pi already. Here, more than 1 already. So 23 over 18 pi is from here to here. Okay, but we know argument cannot be more than 1 pi, right? So means that for the third root, the argument is a negative anchor here, from here to here. So if here to here is 23 over 18 pi, so here to here will be 2 pi. 2 pi is 36. 36 over 18 minus this one, 36. So 13 over 18 pi. The argument for the third root. The argument for the third root is 13 over 18 pi. Because this is 23 over 18, so this is 13 over 18. Alright, so the argument for the third root is 13 over 18 pi because going this direction, right? So negative. Okay, we have to determine the root first. The first and second one, no problem. It's quite direct. Only the third one, be more careful. Because you see, when I calculate, I have more than the range already. So remember, the range is always like this. The range of the argument of each complex number. Okay? Then sub into the formula. So the third root is square root 2. So you see all the modulus are the same. So cos negative 13 over pi plus I sine negative 13 over pi. Alright, so we can put the negative sign outside lah. Okay? Okay, let me see. This is 2014. Okay, so you're asking to express this one in polar form, hence solve the equation. So this one, they just ask you to solve the equation. They never say you have to express your roots in which form, in Cartesian form or polar form. They never say, right? So since this is in polar form, we just left our answer in polar form. So first root, second root, and third root. Because cube root man. Is that clear? So for other question, you also follow the step. Follow exactly the step. Alright, here. Okay, so just now we have labeled, we have sketched the first root and the second root in the Argand diagram. So how about the third root? Alright, so the third root is 13 over 18. So remember pi is 180, so simplify 10. 10 times this one is 130. The anchor for this one is from here to here 130. So 3 roots, right? 3 roots means the anchor between each root should be 120. Right? One circle 360 divided by 3. So they must be equal. So the anchor between each 2 roots must be 120. So you check. This is 10. This is 110. So 120. Anchor between these 2 roots 120. This one. Anchor between here and here. This one 10 ma. This whole thing 130. So minus is 120. Alright. So here 120. Here 120. Here 120. So definitely this one also 120. It must be equal. See or not? Okay. This question they never ask you to sketch the Argand diagram, but I still show you. Because the question that you are going to do, this one in 2017. Find the roots in Cartesian form. They want it in Cartesian form. Then show the roots on Argand diagram. Alright, show the roots on the Argand diagram. Z power 4 means you have 4 roots. 4 roots. Alright, so 3 marks, you see. So everything must be labeled correctly. With the axis labeled, origin labeled, then label 4 line, and make sure the anchor are the same. This is the quiz question. Alright? Okay. So this is question 2. Alright, so the next one is question 5. This is STPM 2008. Okay. Okay, can I? Alright, before I continue, I saw something lah, so just to share with you. So if I have a complex number in polar form, a complex number in polar form, cos theta plus I sin theta. Or actually we can simplify this thing by using CIS theta. No lah, I don't know how to pronounce this. Or CIS theta. So when you see CIS theta means cos theta plus I sin theta. Alright, if you have argument R, then R put in front. Like this. Okay. Just something I saw just now. Alright, so let's see question 5. Question 5. STPM 2018. So you are given a complex number Z has modulus 8 and argument 2 over 3 pi. Remember this part? Find the real and imaginary part of Z. Okay, so we explain this question by using 2 different methods, remember? One is using Cartesian method, solve 2 simultaneous equations to find the x and y. Alright, another one is we express it in polar form. Then change to Cartesian form to find the real and imaginary part. This one we have done. You can refer the notes in front. Alright, so I'm going to do part B. Determine Z power 1 over 2 in Cartesian form. Square root. Okay, so square root means 2 lah. Therefore, this question, actually they never tell you what to use, right? You already have this one. If you already have this one in Cartesian form, so you can use the square root method. This one, you can use this concept. Square root of Z will equals to another complex number. Alright, then you solve simultaneous equation. Also can. Okay, because the question never say anything. But since now we are using the De Moivre's law, the theorem, then we use that method lah. Okay. Alright, so let's see here. Okay, I move it a bit. So A we have discussed, as I said, we have done. A we have done. So we found that Z is equal to 94 plus 4 square root 3 I. Alright, then B. We express Z in polar form. This one also we have learned before this. Polar form very simple lah. Modulus 8, argument 2 over 3 pi ma. Just write only. Okay. So Z to the power of 1 over 2. To use the De Moivre's theorem. So 8 also to the power of half. This whole thing also to the power of half. And this whole thing to the power of half is use the formula 2 over 3 pi, your argument, plus 2k pi over 2. Now your n is 2, so all these are 2 lah. All right, the general one first. Okay, so sorry, I forgot. For the general, you have to write this lah. You have to add this one for the general one. Yeah, here I add that just now. This is the general formula for the root of z. So where k equals 0, 1, 2. Okay, you have to write this one. So for this question, k is equals 0 and 1 only lah. 2 roots only. Okay, then we start. When k equals 0, it's the first root. Alright, so square root of 8 is 2 square root 2 because it's 4 times 2 ma. 4 times 2, so square root 4 is 2. So 2 square root 2. The first one, k is 0. So this is the first argument. 2 over 3 pi divide 2, so it's 2 over 6. 2 over 6 is 1 over 3 pi lah. Okay, because the question one is in Cartesian form. So just calculate lah. Cos 60 is half. Sin 60 is square root 3 over 2. Use the exact form. Don't use decimal. Then 2 square root 2 multiply in. So you get square root 2 plus square root 6i. So this is the first root. Okay, then second root is when k equals 1. So when k equals 1, second root is, so modulus same. So cos 2 over 3 pi plus 2 pi lah. Because k is 1 ma. So plus 2 pi over 2. This one same. Alright, so after you simplify this thing, so you find that it is cos 4 over 3 pi. Alright, so again you see, this argument is more than 1 pi. It's already out of the form. So we have to find what is the actual argument for this second root. Okay, so 4 over 3 pi is like this lah. Okay, 4 over 3 pi means 1 pi and then another 1 over 1 over 3, right? 1 pi and another 1 over 3. So this is the one. So we know that if this is a line represent this second root, so the argument will be this one. Negative angle. So if this is 4 over 3 pi, then this is 2 over 3 pi lah. Alright, because one circle is 2 pi ma. So the argument is negative 2 over 3 pi. Negative 2 over 3 pi. Alright, so again 2 over 3 pi is 120. Okay, because it is in third quadrant ma. Third quadrant. So negative lah. Cos negative. So cos 120. Negative half. So this one also sine this one. Because in third quadrant sine also negative. Okay, so this is 60 ma. Acute angle is 60. So square root 3 over 2 is actually same, you see. It's same. See that? Same. But not conjugate lah. Not conjugate. If this is positive, this is negative, negative. Okay? Not conjugate lah. Alright, then this one multiply in, you get this thing. So first root is square root 2 plus square root 6i. Alright, second root is negative square root 2 minus square root 6i. Alright, so the question one Cartesian form, so you must leave it in Cartesian form. Alright, so this question also never asks you to draw the Argand diagram, but we still show it lah. So that you know how to do it in question 3. Alright, which is your quiz. So same lah, when you want to draw Argand diagram, please label the axis and the origin correctly. Okay, so the first root is x is square root 2, y is square root 6. Let's say this is square root 2, this is square root 6. Okay, so this is your z1. Okay, this one is your z1. First root. Because this one got 2 roots only ma. Alright, so 160 divided by 2, 180 lor. So 180, so definitely this one become one straight line. Okay, this is negative sub 2, this is negative sub 6. Same length, okay, same length. So this is a second root. Alright, so you see this 2 root divided the circle into 2 equal parts. Alright, so this is how you draw your Argand diagram. So this one 2 roots, so 2 lines only. Okay, so this one 4 roots. 4 roots, 4 line. And 4 divided to 4 equal part, 90 degree. So if one is like this, then another one will be like this. Like or what you call it? Right angle. Okay, all must be right angle. It's not same as this question. This question because 3 roots. 3 roots, so 3 equal parts. Alright? 4 roots, 4 equal parts, each one is 90 degree. Right angle. Okay? So it's not difficult, right? Okay, so we have complete chapter 4. Okay, so right after this, please complete your quiz, upload to the Google Drive, And within this week, please complete all the homework. I know it's a lot, but you have to do. Because it's considered a simple chapter that you must score lah. Chapter 3, chapter 4, you must score. Alright? So, you in the notes that I give you, you see that there is one more page that I write extra information. So this extra information is, we are actually using graphical representation of addition and subtraction of two complex number. So we have learned how to add or subtract two complex number, right? No matter it's Cartesian form or polar form. Alright? For this one, we are actually using vector concept to find the addition and subtraction of two complex number. We represent the complex number as a vector. Then if you still remember, you have learned this one in form 5. You have learned this one in form 5. When you want to add or subtract two vectors which are not parallel, so you are using the parallelogram rules. Using the parallelogram rules or the triangle rules. So we are using the same thing to find the addition or subtraction of two complex number, just like two vectors. Alright, I'm not going into this one. This is just for your extra information only. If really come up, if any question in chapter 4, we use the complex number method, either Cartesian form or polar form. We don't use this one. This is just for something extra. But of course, we are going to learn this one in details in chapter 6. Okay, so this is the end of chapter 4. So I really hope that you complete everything of chapter 4 within this week. So next Monday, we are going into chapter 5. Alright, so later I will forward you the notes for chapter 5. So please go through it, especially the first few pages. It's actually some revision of what you have learned, or revision of coordinate geometry that you have learned in form 4. Alright, so you please go through it. So because the revision part, I will go quite fast. So if you go through it first, you will be more understand. Before we continue to conics. For form 6, last time, old syllabus, yes, it called geometry, coordinates geometry also. Okay, but now new syllabus, okay, we actually emphasize on conics. Alright, also I will forward you the new notes, you just go through it lah. Alright, and prepare for next Monday. Okay, alright. Thank you, class. Good day.